Welcome to the Exponential module's Important Questions video, where we'll be reviewing the important questions inside of the Exponentials module for the 2020 Common Assessment Spring preparation. I'm going to start here on number 1. I'll read it first, we'll talk about it, and understand why one of these is the most perfect answer. Let's first focus into the question. Arthur buys a new truck for $22,000. That sounds like the initial value or the starting point of his purchase. The truck loses value, loses means going down, at a rate of 15% per year. Which equation models the value, V of t, in dollars of the truck after t years? Well, let's start with what we know. We know that something like this would be exponential decay because it's losing. So let's use the formula y equals a parentheses 1 minus r to the power of t. You may remember this a as the initial value, the r as the decay rate. So this is the initial value, the r as the rate. And the subtraction comes from the fact that it is losing value. If it was gaining value, I might use plus, but since it's losing value, I use subtracting. So I'll plug in y equals, a will be $22,000. And I might even have to go into the next question and say 1 minus my rate. My rate is 15%. Notice 15% is not necessarily the same as 15. So when I convert 15% into 15, into the decimal, I'll move this decimal over, not once, but twice. We'll go 1, 2, 0.15 to the power of t. Let me now plug this into my calculator. So I'll have 22,000 and 0.85 is what came out of my calculator. I look here and I see they all have 22,000 in the front, but the only one that has a positive 0.85 is letter A. I chose a subtraction because of this losing, but that wasn't enough to make my number inside negative. So this was just a trick. Let's go on to number 5 now. Here, I see number 5 asks this question. If y equals a is an asymptote of the graph of the equation y equals 3 parentheses 0.95 to the power of x, what's the value of a? Well, an asymptote is the line the graph approaches. I'll start first by going into my calculator and starting a new graph. I'll place 3 parentheses 0.95 to the power of x and graph it. Ooh, it looks like it's doing a nice slow curve, but I can't really tell where it levels off. I'll go to Menu, Window Zoom, Zoom out so I can see a little bit more. It kind of looks as if it's just getting really close to 0. Since the line is approaching 0, close to the bottom of this, then I'll say that the value of a is 0. That should be my answer. It gets close to that. Let's go to the next question. Number 7. Which of the following best represents the range of the function here? You know what? I think this is the perfect time to bring back out my calculator. I'll find a new page where I can still do another graph. -3 parentheses 2 to the power of x. This graph is on the bottom of my screen. So if I'm trying to find the range where I find all y's, I'm going to look to see how far up and down things go. It looks like it goes down forever instead of up forever. Let me show you a little bit clearer. It looks like it goes down forever. And if that's true, I think that means that y would be less than. Since it's down forever, it'll go to all the lesser numbers. Y must be less than. It must be specifically less than the middle line here, which is 0. I can see that this says greater so that's wrong. This is less, so it's possible. Greater or equal to, still wrong. Less or equal to. Well, let's decide. It will be equal to if it ever hits that 0. But I know that asymptotes means it'll approach but never touch that line. Since it won't ever touch it, it'll never be equal to. So D is incorrect. It'll only ever get close, so Y is just less than 0. That's number 7. Let's move on. The next problem I want to go over is number 13. Which exponential curve fits this data? When I see something that says fits the data, I think about how I can use my calculator to actually put in this data. I see here the opportunity for lists and spreadsheets. In fact, I've already put in the spreadsheet myself. Let me navigate to it now. Oops, one more. There we go. I'll ask you to pause now to type in this data into yours. Now that you've unpaused the video, make sure you title these two things two names that you'll understand. I love to use in and out to represent input and output. I'll go to my menu, statistics calculations, but I can tell that this needs an exponential curve. So I'll look at all of my options. There it is. The exponential regression is at the very bottom. So I'll press letter A, and let me put in my X list, which I said was in. You can put in whatever you'd like. And my Y list, which I said was out. You can also put in whatever you'd like. Enter, enter, and there you go. This is the format it says. A, star means times, B, and that small arrow means to the power of X. A looks like it's going to be 3.0005. Since I only ever need 3 decimal places, I'll just have zeros. B will be 1.100, 1.1 to the power of X. That looks just like letter A. I can tell that the 3 comes from here, the 1.1 comes from here, and there it is right there. Let's go on to our final question. Here, it shows a new question, a word problem. A company deposits $5,000 in a bank account. Deposits. Deposits is a word that means that we're starting with that kind of money. So I'm going to call it the initial value. That earns 3%. Wow, earns is different than that other problem we did earlier. Earns means we're going to get more money. Which function represents the value V of t in dollars of the bank account after t years? Let's choose to use the same equation from the first problem we did. Y equals A parentheses 1, except a subtraction feels wrong here. I see that we are earning money. So instead of subtraction, if we're earning money, let's put a plus. That'll represent growth. So just like earlier, this is the initial value. So I'll start off my equation with $5,000. I'll keep this 1 plus, keep that t on the edge, but the rate is now 3%. 3% is converted to a decimal by moving it back over to the left side twice. So it needs an extra 0, 0.03. That's 3%. When I add those two together, I can see that I'll have 1.03 to the power of t, which matches perfectly with letter D. I might get tripped up here because this looks a lot like 1.03. And 0.03 is exactly what I had up here. But I know that in order to grow, this number needs to be bigger than 1. So I have to start at 1 and add 3 more percent to show that I am growing by 3 more percent. That's my answer right here for letter D. This is the last problem I'm going over for the important questions. If you have any questions additionally about the exponentials module, I encourage you to ask a friend, ask a teacher, maybe reference a key somewhere. Thank you so much for listening. I hope you have a great day. Like, subscribe, all of those things for Mr. Sanchez. I'll talk to you soon.